for low global warming potential refrigerants, handling hydrocarbon with competence, and lastly but not leastly, the safety concerns for A2L refrigerants and service procedure. Our speakers are 5 of the most well-known experts in the field. We will introduce them, Mrs. White and myself, individually as they come before you. And please leave your question until the end of the sessions, like the format that we have been adopting this last day or so. And kindly, I will ask the speakers to try to stick to 15 to 20 minutes per session, because we are running a bit late and there are some of us who are going to leave just after the sessions. Let me first talk to you about our first speaker. Our first speaker is Mr. Marco Buioni. He is Vice President of the Air Conditioning Refrigeration European Association area. Mr. Buioni is an expert in refrigeration and air conditioning and the chairman of the European Task Force with area since 2010. Mr. Buioni also is an expert on capacity building in RAC and leads many training courses. Mr. Buioni, please come.
Thank you. Very nice presentation. Thank you very much for my presentation. So now we are going to talk about in the field. We talked about in the production, that is important, of course, but in the field is also very important. We should think that in the field we have millions of technicians that want to install, design, repair properly every system, despite what refrigerant is inside there. We want simplicity, we want few rules, we want straightforward mechanism to handle refrigerants, the technicians. So I will discuss about training and certification of technicians, of service technicians, handling in a safe and efficient use alternative refrigerants. We have a good example in Europe, a good method to prove competence of technicians through certification. So I would like to show you first what we have done in Europe. AREA is a refrigeration and conditioning association of contractors, as I told you. We represent 20 associations, so we represent the design, installation, maintenance, repair technicians of every kind of refrigeration and conditioning heat pump systems. I will go very quickly about the background because we talked about it many times. So we would like, of course, to phase down, phase out HCFC, phase down HFCs. We want to move to alternative refrigerants. We should do it in a competent way, and the technicians should know how to handle this refrigerant properly, because we have issue about safety, about flammability, about toxicity, about high pressures. AREA, my association deal with all kinds of refrigerant. So we objectively use every kind of refrigerants with independency, without promoting any refrigerant instead of another. But we, of course, wish to have simplicity, few refrigerants, of course, to have as possible simple rules for the technicians. What is happening in Europe? In Europe is happening something that is working. We have, since 2006, the regulation 842/2006. We need, just to summarize, we need a logbook for the systems. So every system needs a logbook in which you have to write the history of a system. You need to do periodical inspection to this system. So you need to check the system is working properly with no leaks periodically. Annually. But who can do this check? Who can fill in the logbook? Only a certified, qualified technician. This is important. Only certified companies and personnel can buy the refrigerant as well. So this helps to check that the refrigerant is handled only by people that are competent. So we talk about training, but it's not enough training. We need to check that the competence is achieved. So we have minimum competence to achieve the certification. These are the list of what the technician should know, what service technician should know. Is a list that is inside the legislation, the European legislation, 303. So a technician should know theoretically basic thermodynamics, environmental impact of refrigerants, check before putting in operation, checks for leakages, environmental friendly handling. Should know in practice, the practice is very important of course, because we are talking about in-field service and maintenance. So the practical side is very important, should be made certification, assessment to the technician with a practical part, handling the components, the installation of a compressor, the installation of a condenser, of evaporators, thermostatic valve, and then last but not least, the piping, building a leak-tight pipe system in a refrigeration system. This is very important. Both theoretical and practical, with this need to be remembered. So, how it runs the certification? It runs that the technician should have number of questions, theoretically should answer to these questions, and he should pass the theoretical part. Then he has practical session, practical questions. He should do, like you can see in the picture, he should do from the right, vacuum the system, recovery the system from the refrigerant. He should vacuum the system so there is no, is a clear system, is dry, is not. Then you have to do the charge of the system. This is the assessment, the practical side of the assessment. So should know how to check a system, the temperatures, should know the pressure, the subcooling, superheating, to check the system is working properly. And then, at the end, you should know how to do a leak-tight, leak-proof pipe work to check that there is no leak in the pipe work, doing a brazing of the system. This is what is happening in Europe already now. We've done also with the UNEP project about that, certification of technicians around the globe, and is working fine. So it's a good example that I think should be shared with our countries, this assessment, to prove that the technician is competent and is able to handle refrigerant correctly. What in some countries is also happening, and I would like you to invite to have also this system, to register and monitor the person that are certified, because this is important, this is helpful. Not every member state in Europe does it, but it's helpful that there is a list of certified personnel that can be checked by everyone. The authorities can be checked by the customers, of course. The customer can check if the technician that come to your house to install the system is certified. The distributor can check if you are buying the refrigerants from a certified company. So why create training, assessment, certification? I think this is easy to understand, but I would like to underline a few things that are not straightforward. Of course, there are international agreement, policies to reduce refrigerant emissions. This can be helpful. A certification permits, and is permitting in Europe, to reduce the emission of refrigerant, to increase energy efficiency. Again, if the system is working correctly, the energy efficiency is lowering down. The energy efficiency is increasing, the emission is lowering down. To increase the competence, the safety of installation. So a certified personnel can make your system working more safely. Contractors want this certification. They are happy about this certification, most of them. They are happy about this certification because they permit them to show that they are qualified, that they are not one installer like a plumber maybe, no? They are technicians that can handle refrigerants. So they are qualified, certified, very happy about that. The customers, our customers, the contractors, customers, supermarket, big international corporation, likes to have environment-friendly and energy-efficient products. So it's also helpful for them to have certified personnel that can handle this system. So it's required a certification of personnel for this reason. Now, also in Europe, we are moving to alternative refrigerants from HFCs. We are moving to low GWP refrigerants. So as area, we say mind the gap. What means? Means that the training offer and the training needs need to, of course, will result in a shortage of technicians. We have to be careful about these changes. So the technician should be prepared, and we should prepare the technicians for new low GWP refrigerants that has got these issues. As area, we are proposing, of course, to increase the competence also for low GWP refrigerants. We are proposing a certification for alternative refrigerants, and we would like, of course, to address international and European decision maker, of course, to look to low GWP certification. In Europe, the new F-gas regulation says that should be available training courses inside of the member countries that provides alternative refrigerant trainings. And should be a list of these training courses available for the technicians who want to learn more about low GWP refrigerants. Information should be available to the technicians. This is what the rules says in Europe. What AREA is also inviting every member state of Europe, but I invite also members worldwide, to start certification schemes also for alternative refrigerants, dealing with the different nature of the refrigerants. So we would like as area to start in Europe. We started with F-gas certification. This is the basic. From that, we should add a module for each characteristic of each refrigerant. For example, for hydrocarbons, we should add a module for flammability. For ammonia, we should add a module, of course, that cover flammability and toxicity. For carbon dioxide, we should start a module handling CO2. So means we should start a module with high pressures. So the technician should know high pressures. So we started a certification. We have a guidance in our website, in AREA website, showing what can be the certification scheme for alternative refrigerant. This can be used by everybody, of course. This will add to the basic F-gas certification that is working fine in Europe, a module for each refrigerant. For example, hydrocarbons, we need, of course, basic knowledge for hydrocarbons. We need to know thermodynamic properties. What is the differences between hydrocarbons and alternative and HFCs and traditional refrigerants? We should know the toxicity characteristic of the refrigerants, flammability of the refrigerant, material compatibility, oil compatibility for each of these refrigerants. That is, each one is a simple a module. For example, we should know in practice how to identify the application for the different refrigerants. We should know which application are best suited for hydrocarbons, for ammonia, for CO2, and we should know in a practical side identify what refrigerant is inside the system, because it's important that the technician know where it's going and what refrigerant is going to find inside the systems. This is the first rule. The technician should know how to handle the refrigerant, but also to know what refrigerant is inside, select the appropriate tools, the equipment, protection equipment, of course, personal protection equipment, PPE is very important, recovery of refrigerant, venting the refrigerant in a safe way, in accordance with regulation, of course. So it's very important that we address all these different characteristics for each refrigerant. For example, for this refrigerant, it's very important the health and safety requirements. We are not talking about that in the F-gas regulation we have now, but health and safety requirements, safe system, shutdown, insulation, extinguish a fire, first aid care for fire burn, first aid care treatment for frostbite are very important using these new alternative refrigerants that are not new but are alternative refrigerants, so will be used more and more in the future. Another and last part of this certification process will be, of course, the regulation and standards. The technician should know, in principle, what are the regulation and standards reflecting this refrigerant. It's not like a traditional refrigerant. Now you should know more about regulation and standards, of course. So you should know more about what is the standards for that kind of refrigerant. An important issue at the moment is the equipment, the tools that we should use for the alternative refrigerant. There are not many available. So we should assess our equipment to check if they are correct with the alternative refrigerants. We should check that they are flammable proof. The leak detector should be a proper leak detector for flammable refrigerants. Last week, 2 weeks ago, was an important exhibition in Germany. There are not many available equipment in the market. So when you're going to alternative refrigerant, be sure that your equipment is properly adapted for, is properly assessed for this alternative refrigerant. Recovery units. Of course, CO2 you don't need to recover, but the other refrigerant you need to recover. So please be sure that the recovery unit is correct. Charging station, we talked earlier about the charging station for the new HFOs. So should be a charging station for automotive, for example, that is addressed for this refrigerant. This is another long list about characteristics that should have the equipment you are going to use for alternative refrigerant. We are going to do a guidance as a RARE with the properties they should have, the equipment that the contractor should have to handle this refrigerant. This is very important for the protection of the installers, but also, of course, at the end, for the protection of the user of equipment. Concluding, I would like to promote this project. It is a European project. Is Real Alternatives, is a project financed by EU. We are going and we are in the piloting testing session now. We are doing a blended learning that include also an e-learning for alternative refrigerants. It's available in the Real Alternatives website. You find easily on Google. And we are in the piloting part now, and beginning of 2015 we will have it ready. It's an e-learning and can be used to start learning on alternative refrigerants, especially the theoretical part, but of course the practical part that is even important, maybe more important than the theoretical part, should be made in class, of course. Practical part is very important and should be added to the theoretical part. And we are proud also to have among our stakeholders the European Commission and UNEP on this project. So, thank you, and I would like to say as a last sentence that to preserve our water, to preserve our climate, to preserve our environment, I think we should change refrigerant, but we should do it with competence. Thank you very much.
Thank you very much, Marco, for your presentation. We are now going to move from an Italian accent to a Danish accent, and from Europe to China. Mr. Ole Nielsen is going to tell us about hydrocarbons in air conditioning equipment in China. Ole Nielsen, you saw him already several times during that symposium. He graduated from the Technical University of Copenhagen in 1988, and he has been involved with the Montreal Protocol for over 20 years. So we are very happy to have him here and to listen to what he's going to tell us about China. Thank you, Ole.
Thank you for the introduction, and ni hao, ladies and gentlemen. I think the moderator forgot to mention that I'm doing this presentation on behalf of the Chinese Household Electrical Appliances Association, short CHEA. CHEA unfortunately couldn't participate this event because they have their annual conference next week, so they are all very busy, so they kindly asked me to present on their behalf. I have to say I received a presentation from China in Chinese, and I have done a translation with help of good friends and colleagues, but please bear with me if it's not all very fluent. I would like to start elaborating a little bit on risk assessment. We just heard in the previous session that a thorough risk assessment has been done for products. We also heard that we are getting wiser all the time, and the same happens in China. As you know, there is a massive conversion into propane R290 in China, but there is also an ongoing development of the product with the aim to simplify the measures needed for the product and of course to reduce the associated costs. I should also say that to respond to a question from Samir from Bahrain, that in China the initial focus was on split air conditioner, but we heard yesterday that China have applied snap approval of R290 for window air conditioner. So I can confirm there is also an ongoing research on window air conditioner with R290 in China. The other side of the medal is the risk assessment of the application, and that's the topic I would like to elaborate about. But before doing this, since the title is broad, I would just respond to another question that came yesterday from the audience, whether the Praha project did have any risk consideration when they selected refrigerant and the product types. And yes, we actually did so. You may recall this diagram from yesterday, and the red areas are those applications that we will not do with certain refrigerants. That was actually based on a risk assessment from the technology providers. Just to respond to that question from somewhere here yesterday. But in China, there is an ongoing massive conversion into propane. We heard yesterday 18 lines will be converted by the end of next year, with a total expected output of 6 million air conditioners per year, and all into R290. In parallel, there is a massive research program going on. I listed here a few of the topics which are being investigated. Of course, charge reduction is a key issue, but also R290 distribution in case of leakage, how the refrigerant is distributed within the air conditioning unit, or how to improve the heating performance. A long range of things are ongoing, and as a matter of fact, I wish I could give you an update, but I will only learn it next week at the annual conference in China. Wow, so that's something I inherited and made English. Now it's all animated. Let me do like this. In China, the consequence of moving from R22 into a flammable refrigerant also called for the need to have a standardized system for installation and maintenance. This is one of the key issues in order to penetrate the market, and such activity has been initiated by the Chinese government in cooperation with CHEA. This is the organization of the working group elaborating on the standard for installation and maintenance. It's all chaired and organized by CHEA, but we have participation from Chinese university. We have a large participation from the Chinese industry. You can see all the major players here, as well as we have also participation from the refrigerant supply chain. So I believe that is a good foundation to come up with a very nice recommendation for a standard. I have to say the usual approach in China when doing this kind of work is to do a study of available existing standards. No need to reinvent the wheel, so this is always the first issue. Review what is available, pick what is applicable. And this is the structure of the proposed standard. It is currently it has been drafted and it's being internally reviewed in China within different government bodies and associations. It will have 10 paragraphs, very much following the standard template. It will have a scope, references, definitions. It will deal with the requirements for the technician skills, requirements for installation, requirements for relocation, requirements for servicing, requirements for dismantling and disposal, requirements for transportation, and finally requirements for maintenance. Sorry, I need a glass of water. Some will say this is a consequence of smoking. I believe it's not. Further, the standard will also have 3 annexes. One will deal with the charge of refrigerant allowed. That will be one outcome of the research projects ongoing. The next annex will deal with the necessary labeling for hydrocarbon appliances. And finally, the third annex will describe the minimum and necessary tools to service and install an R290 air conditioner. Now I will walk you through the major parts of the standard. First of all, it's applicable to all standards that meet the national standard GB 7725, which is the IEC standard, as we heard yesterday, presented by the Chinese government. The standard will describe all the safety requirements for flammable refrigerants during the installation, during maintenance, during relocation, disposal, and during transportation. The training and qualification is planned in the following manner. The refrigerants will be grouped in 3 categories. I'm not able to share with you how they will be grouped. I will investigate that and then share with you maybe next year. But there will be a specific training requirement for each category. Again, that falls very well in line with the previous presentation by area. There will be thorough requirements for the installation, and of course a key requirement here is safety. And during installation, this is basically avoid any sources of ignition and ensure proper ventilation. Also, the standard will prescribe that you have to investigate the location where you will mount the air conditioner prior to installation, ensure that it's grounding, and ensure unpacking can take place in a safe manner. There are some technological issues that should be considered, and they are listed here, in particular where you mount indoor and outdoor unit, how you connect them, and finally but not least, in case the connecting pipe between indoor and outdoor unit exceed the standard, you should know exactly how and how much additional refrigerant to charge. In case of relocation, again, safety is the key issue. And first of all, you need to check that the air conditioner is free of leaks before moving it anywhere. If that's the case, you can move it, and then the reinstallation should follow the normal procedures for first-time installation as described in paragraph 5 of the standard. Also, disposal is a key issue. And again, during disposal, safety has to be observed. First of all, it's very important to discharge the R290 in a safe manner. And only when that happened, you can start the dismantling. Discharging of R290 can be to atmosphere according to certain procedures. Finally, transportation is an issue. According to the standard, we should ensure that there are no sparks possible during the transportation, so anti-static protection and also proper ventilation. And finally, I would say that should be applicable for all product. Avoid any harsh handling, throwing around, or shock of the equipment. Finally, the standard will have safety requirements for maintenance, and the standard will be divided in two parts here. One will be the safety requirements for maintenance in the field, and the other one will deal with safety requirements if maintenance will take place in the workshop premises. Sorry. I don't know the details about these requirements, but that is all to come. And that's actually my last slide. I was told I have 10 minutes only, so I think I'm there. But I would like to say all the R&D that goes on in China is in principle Chinese property, but we will make sure that this will be available for everyone, because I believe this would be a very important tool to ensure low GWP refrigerants to be applied outside China as well. Thank you.
Thank you very much, Mr. Oli Nilsson, for a very informative presentation. It gives me great pleasure to introduce our next speaker. He will speak about the safety guidelines for low global warming refrigerant from a compressor manufacturer point of view. He is Dr. Rajan Rajendran.